Welcome to today's explainer. Right now, just take a quick second and look up at the ceiling above you. For most of us, a roof is totally out of sight, out of mind, right? Just a layer of shingles and some nails up there keeping the rain off our heads. But listen, if you live in a coastal climate, particularly down along the Gulf Coast in places like St. Pete, Florida, that simple assumption is basically a recipe for disaster. In these environments, your roof isn't just a basic covering. It is a highly engineered, storm-tested defense system that is actively fighting off a brutal and relentless climate. So today, we're going to completely change how you look at the very top of your house. We're unpacking the fascinating engineering, the extreme weather codes, and the hidden science that actually keeps coastal homes standing when the sky falls.
Okay, let's dive right into this. Here's how we're going to dissect this critical architectural shield today. 1. The Gulf Coast threat. 2. Anatomy of roof failures. 3. Surviving the hurricane zone. 4. Choosing your armor. And 5. The replacement reality. Let's get started.
Section 1. The Gulf Coast threat. To really understand the engineering here, we first have to understand the enemy. Take Saint Petersburg, jutting right out into Tampa Bay. The homes here are actively attacked from literally every direction. Let's start with this number, 50. That is the number of inches of rain dumped on this area every single year. And we're not talking about a gentle spring drizzle. We are talking about aggressive, wind-driven afternoon thunderstorms that forcefully test every single seal, every valley, and every penetration on a roof. The water is just relentlessly probing for a way inside. And then, well, when the rain stops, the sun takes over. Proximity to the equator down there means the UV intensity is so high, it degrades asphalt shingles up to 30% faster than it would in northern climates.
But the heat isn't just an external threat. This is where things get really wild. 160. That's the temperature in degrees Fahrenheit that an improperly ventilated attic can hit during the peak of summer. Modern, energy-efficient homes are often sealed up so tightly that they end up trapping this massive amount of heat right under the roof deck. It essentially acts like a giant oven, literally cooking the shingles from the inside out, warping the wood, and accelerating the deterioration of your underlayment way before a storm even hits.
And you know, the attacks aren't just from above. Your roof is caught in a complete pincer movement. From the air, you've got salt-laden wind blowing in off the Gulf, depositing this highly corrosive moisture all over the roof's metal components. At the exact same time, from down below, the region's sandy soil and high water table cause foundations to settle a lot faster than they would inland. This shifting ground puts immense mechanical stress on the roof framing. It's literally pulling at the seams and creating brand new leak points around things like chimneys and skylights. It is a constant battle on two fronts.
So how exactly does this defense system break down? Let's look at Section 2, Anatomy of Roof Failures. Now, what's really interesting here is how simple chemistry can absolutely destroy thousands of dollars of construction. We mentioned salt air earlier, right? Well, when standard galvanized metal flashing is exposed to constant coastal salt air, it undergoes what's called galvanic corrosion. Standard inland metals will actually fail in under 5 years in a place like St. Pete. It acts almost like battery acid on the roof's most vulnerable weak points, the valleys and the flashings, creating these invisible gaps where water quietly seeps right into the decking.
And that brings us to the wind. You see, hurricane damage is almost always a slow, invisible chain reaction. It's a total domino effect. It starts with improper fastening. If a contractor just used generic inland installation methods, high winds are going to cause the shingles to slightly lift rather than just blow completely off. Honestly, you probably wouldn't even notice it from your driveway. But under that lifted shingle, wind-driven rain gets pushed right into the underlayment. Over multiple storms, this repeated lifting completely breaks the seal strips. Moisture gets trapped, rotting the wood from underneath. So by the time the next major 100+ mile per hour storm hits, the foundation of the roof is already compromised, leading to a catastrophic failure. And the real kicker? When the insurance adjuster finally comes out, they'll see that improper original fastening and just deny the claim. So how do you stop this domino effect from happening to you? Section 3, Surviving the Hurricane Zone. The difference between standard inland building and Florida coastal building is literally night and day. In a northern or an inland climate, contractors might use a standard 4-nail fastening pattern for generic shingles. But in a high-velocity hurricane zone, the code actually mandates a 6-nail pattern. Those 2 extra nails change absolutely everything. Furthermore, the code requires completely sealed roof decks, meaning every single seam is taped and secured, and heavy-duty hurricane straps that mechanically tie the roof trusses directly down into the wall plates of the house. This stops the entire roof from catching aerodynamic lift and just flying off the structure. And this brilliantly illustrates why these extreme engineering codes are non-negotiable. Look at this quote from Crestline Roofing Tampa. This isn't just some marketing boast, it's real-world proof of survival. When Hurricane Idalia was pushing water under poorly installed roofs all across the coast, the heavily engineered systems, the ones actually using the 6-nail patterns, the sealed decks, the exact manufacturer specs for closure strips, they held their ground against sustained 100-mile-per-hour winds. Proper engineering literally saves the home.
Knowing the code is one thing, but what actual materials are going on your house? Let's check out Section 4, Choosing Your Armor.
So the crucial point is balancing cost, lifespan, and resilience here. Asphalt shingles are definitely your most budget-friendly option, lasting about 15 to 20 years in Florida's harsh sun, provided you use the heavy architectural variants that are specifically wind-rated. Then you've got tile roofing, made of concrete or clay. Incredibly durable against storms, lasting over 50 years, but it demands highly specialized flashing. But look at metal roofing. Lasting 40 to 50 years, especially with a standing seam design, it gives you superior uplift resistance against hurricane winds. Plus, it actively reflects that intense UV heat we talked about earlier, which massively reduces your cooling costs. For coastal environments, metal is often considered the ultimate armor.
Now, how does this actually get done? Section 5, the replacement reality.
Let's move to and see how this all builds into a finished, storm-ready product. It happens in 3 very rigid phases. First up, assessment and planning. This isn't just pulling out a tape measure, it's getting city permits and meticulously verifying structural integrity. Second, installation and quality control. This means stripping the roof entirely down to the wood, replacing any rotted decking, and flawlessly executing those 6 nail patterns. But step 3 is what actually saves you in the long run: final inspection and documentation. In the modern insurance landscape, your contractor absolutely must provide photographic proof of the tear-off, the underlayment, and the nail patterns. Without that paperwork and the permit closure, your insurance company can simply refuse to cover you when the next storm hits. I mean it, the documentation is just as critical as the nails themselves. Which brings us to our final thought. The next time you pull into your driveway, look up. Ask yourself this question: is your roof just a pile of shingles and generic nails slowly cooking in the sun? Or is it a carefully documented, fully engineered defense system built with exact chemistry and physics to withstand the next 130-mile-per-hour storm? In a changing, aggressive climate, assuming you're safe just isn't enough anymore. You need to know your armor is ready. Thanks so much for joining me for this explainer, and keep learning.